All right, everyone, the last two sections of Chapter 8, critical paths and the critical path algorithm. So, first things first, let's talk about critical paths. Critical path for vertex task X. This is the path from X to the end with the longest total processing time. How do we get the critical time? It's the total processing time of all tasks on that critical path. So if you add up all the numbers along the path as you go, that's your critical time. Your critical path for the entire digraph is the path with the longest processing time that goes from start to end. So your critical path for a vertex may start in the middle of the digraph and go to the end. Or it may start at somewhere around the beginning and go to the end. Your whole entire digraph has to go from beginning to end. And again, the critical time is still the total processing time of all the tasks along that path from the start to the end. So, let's find some critical paths here. As I scroll down. Okay, so here's the digraph. We want to find the critical path and time for these vertices. So, number one wants us to start at HU. So, it wants us to start here. What is the longest way for me to get to HU to the end? Well, let's break it down into how many different ways I can go. I can go from HU to IC, from IC to FW, to the end. That's a total of 4, 5, 11. Okay, I can also go from HU to PD and PD to the end. That's 4, 3, that's 7. And finally, I can go from HU to EU, and from EU to the end, that's 4 and 2, that's 6. So HU, IC, FW, end is going to be my critical path. Okay, number 2 wants us to start at AD. So we're starting here. AD. The only way to leave AD is to go to ID. From ID, I have to go to PU. From PU, I have to go to EU. Remember, you can only travel in the direction that the arrow points. And from EU, I go to the end. So that's 8, 5, 3, that's 16. That's 18. And that is going to be my critical path. That's the only way to get from there to the end. Number 3. Wants us to start at IW. IW, I can go to IP. IP to HU. HU to PD, PD to the end. That's 7, 11, 15, 18. There's several options here, so let's see. Instead of going PD to the end, I can go IW to IP, to HU, to IC, to FW, to the end. That's 7, 11, 15, 16, 22. Did I have that right? Okay. I can also go IW, IP, HU. Instead of going to PD, I can go down and go to EU to the end. It's 2, 6, 10, 17. Okay. I can go IW to IP, IP to PU this time, PU to EU, and EU to the end, so that's 2, 5, 9, 16. I have one last option, IW to ID, ID to PU, PU to EU, EU to the end. So that's 2, 5, 10, 17. Okay, so this is going to be my critical path from IW. And then your critical path overall. I'm just going to give it to you here because it's going to be way too hard until I teach you the trick. So your critical path from start to end goes from start to AP, down to IF, down to IW, to IP, to HU, to IC, to FW, to the end. So it's start, AP, IF, IW, IP, HU, IC, FW, and that's a total of 34. Okay, observations or problems? One, the farther you are from the end, the more options. Chica chica. Sorry, my dog's being bad. The more arcs, the more options. Okay. So we're going to use something to help simplify it called the backflow algorithm. So step 1, we want to find the critical time for every vertex of the project digraph. So what we're going to do is we're going to work backwards. We're going to begin at the end and we're going to work backwards towards the start according to the following rule. Your critical time is the task processing time plus the largest critical time from the back to the front. Okay, so in other words, always add the largest critical time backwards into the task processing time. So we can randomly choose in case of ties, as the time will still be the same. Okay, so remember, our processing times are in parentheses. So in order to distinguish between processing time and critical time, we're now going to put the critical time in square brackets instead of in parentheses. Okay, so here we go. Example of step 1. What is the critical time for vertex X? So vertex X is over here. Oh, did it again. Vertex X is back here. What is the longest time from any one of these points back? Well, if I go from A to X, that's 10, B to X is 15, C to X is 12. So, critical time for X is going to be 15. It's the longest time from any point backwards. Okay. So let's jump down to example 1. Find the critical time for each vertex in the given digraph. Find the critical path and its given project diagram. So we're going to start at the end. Okay, let's work backwards. If I go from the end to F, that's 0 and 6, that means F has a critical time of 6. End also goes to G. G is going to have a critical time of 3. And end goes to H. H has a critical time of 2. Okay, so now I need to work backwards from these points. F goes to 5, or I'm sorry, F goes to C. 6 and 5 gives C a critical time of 11. 6 plus 5 gives me 11. G goes into D. 3 and 4 gives D a critical time of 7. And H goes into E. 2 and 7 gives E a critical time of 9. Okay, notice when I work backwards into B, I can either go from C to B or D to B. Which one's going to give us the biggest time? Is it 11 and 2 or 7 and 2? What's going to be this 11 and 2, which gives B a critical time of 13? You always want to go with the bigger time. 7 and 2 give me 9, 11 and 2 give me 13, so B is going to have a total of 13. And E goes backwards into A, so 9 and 1 give A 10. And then backwards into the start. So my critical, my biggest number that goes backwards into start is a 13. So that's going to be my critical path. So my critical path then is going to be to B. 13 minus 2 is 11, so that takes us to C. 11 minus 5 is 6. That takes us to F. 6 minus 6 takes us to the end. So start, oops, I don't want the highlighter. It's start to B to C to F to end. Okay. Example 2. Find the critical time. Find the critical path. Okay. So we've got to go with the critical time first. Again, N goes to D, which gives D critical time of 2. N goes to E, that gives E a critical time of 5. D branches off into A and B. So if I go from D to A, that gives A a critical time of 8, B a critical time of 7. E goes backwards into C, that gives C a critical time of 12. All three of these go back to the start. Your biggest number is a 12. So your critical path then is my path with a length of 12. So that's from start to C to E to the end. Find the critical path for task A. So the longest way from task A. So that's A, D, end. Starting at task C, that's C to E to end. And critical path for task D, well, that's just D to the end. There's really not another option there. Okay. If we have time, we will come back to this one. This one is long and difficult. If we have time, we'll come back to it. Okay? So, why are the critical paths and critical times significant? What makes them special? A critical path is a specific order. That tasks must be completed in. So this means any task in the path cannot be started until all tasks before are complete. So in other words, you'll never see tasks out of order from the critical path. Never see tasks out of order from the path. Your critical time then is your minimum finishing time that the project can be completed in. Can be longer but never shorter. Okay. Can be longer but never shorter. Okay, what this means, let's go back to example 2. Okay, we said our critical path was from the start to C to E to the end, which took a total of 12. Okay, that's the number we got at the start. This means when I go to schedule these, my time, my finishing time will never ever be lower than 12. Okay. All right. Last section, and then like I said, if we have time, we'll go back and do that big graph. If not, I'm not too concerned about it. You won't see anything that big on your test. We can now use the concept of critical paths to create very good, although not always optimal schedules. Creating schedules will require needing critical time priority lists. So, the priority lists of tasks written in the decreasing order of critical times, with times broken randomly. So, we have to go back, we have to do, find the critical times for each task. Then we need to create your critical time priority list. So it's just like the decreasing that we did in section 8.4, except instead of using the processing times, the ones in parentheses, we're going to use the critical times, the ones in brackets. And then we're going to go ahead and create the schedule using the priority list and the digraph. So, this first example, I already gave you all of the critical times. Okay, again, they're the ones in the brackets, not the ones in the parentheses. Okay, so the first thing we need to do is come up with our priority list. What needs to be done first? So our biggest critical time is B. Remember, we're looking at these. Okay, when we create the priority list. Critical path algorithm means critical times. So B, C, A, E, D, F, G, and H. Gotta erase these or I'm gonna confuse myself. Okay, so we still have to follow the digraph according to what can be used. Now, remember, when we schedule, we're not scheduling by critical times, we're scheduling by processing times, the one in parentheses. So please be careful there too. So the only two tasks that are ready off the bat are B and A. According to my priority list, B should be scheduled first, and B takes a minute to complete. A should be scheduled next because C is not ready, and A takes a minute to complete. Okay. Those are my only two ready tasks. After a minute, processors 1 and 2 are both finished with B and A. When B and A are finished, that means C is ready, D is ready, and E is ready. C, E, and D are all ready. C is the next one I should schedule according to my priority list, so that takes me out to 6 minutes. E is the next one I should schedule, and that's 7 minutes, so that takes me out to 8. Processor 1 finishes first with task C at the end of 6 minutes. When C is done, F is now ready to schedule. So D and F are both eligible to be scheduled. D comes first in my priority list, so D gets scheduled first, and that takes me out to 10 minutes. At 8 minutes, E is now finished, which makes H eligible. The next one ready to go according to my priority list is F, so that gets scheduled next, and that's 6 minutes. That takes me to 14. At the end of 10 minutes, D is now finished. which means G is eligible. According to my priority list, G should be done before H, and both of them are eligible, so G gets scheduled next. That takes me out to 13. G is done at 13 minutes. H is ready to go, so H gets scheduled. That takes me out to 15, which means we idle here. So I have finishing time of 15 minutes. Okay. Example number 2. Use the critical path algorithm with 2 processors for the given project digraph. Okay, so this time I did not give you critical times. We have to do those first. So remember, we always start from the end. N goes to G, which means G has 4. N goes to F. F has 5. F leads to C. That's the only thing that leads to C. So C has 8, 3 and 5. F and G both lead backwards into D. The longest path to D, though, is from F. So that gives D a processing time of 11. G is the only one that backs up into E. So E has a critical time of 11. We've got 3 ways to get back to B: C, D, or E. The longest one is either D or E. They both have 11, which means B has a critical time of 13. E is the only one that leads back to A. So that gives A a processing time of 19, which means my start, when I schedule, this should take 19 minutes or longer. Okay, it should never be shorter than 19 minutes because that's what leads back to my start. So, priority list. Let's see, my longest critical time is A, then B. D and E both have the same, so it doesn't matter what order you put them in. C, F, and then G. Switch up colors here. Actually, let me scroll. Let me scroll a little bit first. Okay, now let me switch up colors here. I scrolled too far. Of course I did. Okay, now let me switch up colors here. Okay, so off the bat, A and B are the ones that should be started. They're the only ones eligible from the start. Okay, according to my priority list, A should be done first, so we will schedule that first with processor 1. And then B, we will schedule that with processor 2. B only takes 2 minutes to complete, so at the end of 2 minutes, processor 2 needs something to work on. When B is finished, C is now eligible, and D is now eligible. So D and C are both eligible. According to my priority list, though, D should be scheduled first. So we need to go ahead and schedule D. That takes 6 minutes, so that should take me out to 8. Both processors finish at the same time at this point. So at 8 minutes, A and D are both finished, which now makes E eligible. That's it. So E and C are now eligible. According to my priority list, E should be scheduled first. So we're going to schedule E. That takes me to 15 minutes because it takes 7 minutes to do. And C is 3 minutes. So that takes me to 11. At 11, C is now finished, which now makes F eligible because C and D are both finished. So F is eligible. G is not eligible yet because E is not finished. E needs to be finished before G is eligible. So F gets scheduled next. That's 5 minutes. That takes me to 16. At the end of 15 minutes, E is now finished, which now makes G eligible. So I can schedule G now, and that takes 4 minutes. That takes me to 19. Everything is scheduled, so we idle here, and my finishing time is 19 minutes. Now let's see, 19 minutes and 19 minutes. If you go back and look at this one, 12 minutes, oops, not mean to shake that all up, 12 minutes, this took longer, that's okay, it just cannot be any shorter than 12 minutes. Okay. 2 more examples. And then we'll go back and do that big one because it's fun and I'm crazy, but that's okay. First things first, critical times. End leads to C, that gives it a critical time of 4. End leads to I, that gives it a critical time of 3. C leads backwards into B. It's the only thing that leads backwards into B, so that gives B a critical time of 6. 4 and 2 is 6. I goes backwards into F, so that gives F critical time of 8. I goes backward into H, so that gives H a critical time of 11. B goes backwards into A. That gives A a critical time of 11. There's 2 that go backwards into E. My biggest one is 8 though, so 8 and 3 give me 11. There's 2 that go backwards into D. Both of them are 11, so it doesn't matter which one. So that makes D 17. And H is the only one that goes backwards into G, so that gives G 18. So my priority list then is going to be G, D, A, E, H. Those could be done in any order that you would like because they're all 11. F, B, C, I. All right. And it's time to schedule. All right, off the bat, A, D, and G are ready. G, D, and A. So according to my critical time priority list, G should be scheduled first. That takes me out to 7. D gets scheduled second. That is 6. A is scheduled third. That is 5. Okay. 3 processors. The first one finished is processor 3 at 5 minutes, and they are done with task A. Nothing becomes eligible when task A is finished. Okay, so processor 3 is going to have to idle because nothing is ready until the next one is done. The next one is done at 6 minutes. At 6 minutes, D is now finished. When D finishes, we've got 2 that become eligible. Oh, I'm sorry, no. Just E. E is the only one that becomes eligible. So E is now eligible. You can give it to either processor because they're both open. Okay, so E is now eligible, and E takes 3 minutes, so that takes me to 9. Okay. Because processor 2 or processor 3, however you scheduled it, has nothing to do right now until the next task is finished, they will idle. My next task finishes at 7 minutes. G is done. When G is done, H is now eligible. F is still not eligible because E is not done. B is still not eligible because E is not done. And I'm not even worried about C and I right now because that's way too far out there. Okay, so H goes next. And H takes 8 minutes to complete, so that takes me to 15. Again, we only had one task open, so the open processor has to idle until 9 minutes when processor 3 finishes task E. When E is finished, that opens up B and F. I have 2 processors open, so F can go with processor 1, that takes me to 14. And B can go to processor 3, that takes me to 11. At 11 minutes, processor 3 is done with task B. That opens up task C. Task C can be scheduled, and that takes 4 minutes. That takes me to 15. At 14 minutes, though, task F is finished. I is still not eligible, though, until H is done. So we must idle. H and C both finish at 15 minutes, which makes I eligible. We schedule I, that takes me to 18. And the other 2 will idle for that last 18 minutes. Look at that, my biggest time here is 18, my finishing time is 18. Okay, last example. Woo! N goes to H, which gives H a critical time of 2. I has a critical time of 5. And J has a critical time of 3. Okay, all 3 of these lead into G. My biggest one, though, is I, so from I to G gives that a critical time of 9. H is the only one that goes into D, so D has a critical time of 7. J is the only one that goes to F, so that gives F a critical time of 7. Okay, D and G go into E. My biggest one, though, is from G to E, so that gives E a critical time of 12. D is the only one that goes to, oh no, I lied. D and E go into A. My biggest one is E into A, so that gives A a critical time of 19. Okay. E and F go into B. E is my biggest one, so B has a critical time of 17. And F is the only one that leads into C, which gives C a critical time of 13. Okay, so that makes my priority list, my critical time priority list, A, B, C, E, G, D and F both tie, I, J, and H. Okay, so off the bat, A, B, and C are ready at the get-go. Okay, according to this, A should be started first. So A takes 7 minutes. B should be scheduled second. That takes 5 minutes. C should be scheduled third. That takes 6 minutes. Scheduled, scheduled, scheduled. The first task to finish is going to be B at 5 minutes. Unfortunately, no tasks open at that point. E cannot be started until A is finished now. F cannot be started until C is finished. So, processor 2 must idle until my next task is done at 6 minutes. At 6 minutes, C is now done and F has opened. Okay. So, F can be scheduled and that takes 4 minutes. That takes me out to 10. Okay. Because we only had one task that opened up, that means the other processor, the open processor, which I have as processor 3, needs to idle until my next task is finished. So it's going to idle until 7 minutes when we finish with task A. E is now eligible at that point, as well as D. Oh no, not D. I lied, not D. E is the only one opened. So E can now be scheduled. And that takes 3 minutes, so that takes me to 10. Okay, E was the only one to open up. So therefore, we need to idle until my next tasks are done at 10 minutes. At 10 minutes, E and F are finished. All right, so we're finished, 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 finished. That means D, G, and J are all opened. D, G, and J. So G should be scheduled first. That's 4 minutes. D should be scheduled second. That's 5 minutes. J should be scheduled after that. That's 3 minutes. The first task done of those 3. Ooh, back that up. J is not ready yet either. Look what leads into J. F and G. So we must idle until G is finished at 14 minutes. We're getting a lazy processor down there. At 14 minutes, G is now finished. Now J is ready to be scheduled. Or I. Okay, because I comes first, I is going to be scheduled here and it takes 5 minutes. J will be scheduled here and it takes 3 minutes. At 15 minutes, D is now finished. When D is finished, H is now ready to be scheduled. So I'm going to schedule H. That takes 2 minutes. So that takes me to 17 when H and J are finished. And both of these will idle until my finishing time of 19 minutes. And again, my biggest critical time here was 19 minutes. My finishing time matches that. So we are good to go. Okay, we're going to go back and look at that big old one and see if we can come up with all these critical times. Just because it's fun. Besides, if you can do the big one, you should be good to go. All right. What did it just do? Okay, working backwards from the end, that gives this a critical time of 6, 3, and 2. Okay, FW leads backwards to IC, that gives IC a critical time of 7. 3 lines lead back to HU. Your biggest one is IC, so that makes this 11. EU is the only one that goes back to PU, so that gives me 5. Both of these lines go back to IP from HU and PU. My biggest one is 11, so that makes this 15. IC goes back to PL, so that gives me 11. PU is the only one that goes back to ID, so that gives me 10. Both of these lines, ID and IP, lead back to IW. The biggest one is 15, so that's going to make IW 22. ID is the only one that leads back to AD, so that makes this 18. IW is the only one that leads back to AW, so that makes this 28. You've got 2 lines, PL and IW, both lead back to IF. The biggest one is IW with 22, so that makes IF 27. IF leads back to AF, so that makes this 32. And IF leads back to AP, that makes that 34. So, find the critical path and its time. My critical path goes to AP, IF. 27 minus 5 is 22, so that takes me here. Minus that processing time of 7 takes me here. Processing time of 4 takes me to 11. Here is your critical path. So that is start, AP, IF, IW, IP, HU, IC, FW, and 34. Find a critical path and time for IF. So we have to go from IF to the end. Well, that's just your critical path here, except no start in AP. So we start at IF, IW, IP, HU, IC, FW, end. Okay, and at IW we had a critical time of 22. And critical path and time for AW. So that's AW to IW to IP to HU to IC to FW to the end, and that was 28. Again, if you take your time and think through these, you'll be okay. Okay, so that leads us to your homework for tonight, which is way down at the bottom of your packet here. Page 312, numbers 45, 46, and 48. And that is the end of chapter 8. Your review will be in class tomorrow on GoFormative and your test on Friday.